Okay, students, so we're here with Unit 4 Transformations and Triangle Congruence Test Review. So let's just dive in. Translation stuff. Our first transformation is translation. And remember, it's just literally addition and subtraction. And if you're good at counting, you're going to be good at translation. So we got point B with these coordinates right here, 4, -2. We're going to translate point B according to the rule xy arrow x minus 5, y plus 3. So remember, that's left 5, up 3. That's how we get b prime. Then we're going to do another transformation to get to b double prime, xy arrow x plus 2, y plus 4. So right 2, up 4 to find b double prime. What are the coordinates of b double prime and define a single translation that maps b to b double prime? So we're going to be a little sneaky. We're going to find b double prime without ever finding b prime. How are we going to do that? Well, let's first just find the single translation. All right, so I'm going to write both translations on top of each other. I'm just going to rewrite them, x minus 5, y plus 3, and then this is the second one right here, x plus 2, y plus 4. All right, so remember, this is just sliding, this is just counting. All right, so I can take both of these and combine them into one. All right, instead of going left 5 then right 2, oops. Instead of saying going up 3 then up another 4, I'm going to bash these together and get this golden rule right here, xy arrow. What's x minus 5 plus 2? Well, that's just x minus 3. What's y plus 3 plus 4? Well, that's just y plus 7. All right, so this is the single translation. All right, instead of saying going left 5, right 2, up 3, up 4, we just bashed it all into one. All right, now let's recall. Let me write some things over here. I'm just going to rewrite the coordinates of b, which was 4, -2. All right, I'm going to take 4, -2. I'm plugging in this rule right here. XY arrow is going to be 4 minus 3, -2 plus 7, and it's going to tell me the coordinates of b double prime. Well, what's 4 minus 3? 1. What's -2 plus 7? 5. So 1, that's kind of a weird looking 1. 1, 5 is the answer. 1, 5. Okay, so that's how you do that problem right there. Let's cruise right along. The vertices of F, G, H are F, -4, 3, G, 3, -1, and H, 1, -2. The coordinates of F prime are -1, 4 after the translation. Determine the rule of the translation using coordinate notation. So this problem right here, all we have to do is focus on this. Let's focus on F and F prime. All right, well, -4, -1. All right, what do I have to do to get from -4 to -1? I have to plus 3. What do I have to do to get from 3 to 4? Well, I got a plus 1. All right, so that's what I'm moving. So what I can do is I'll actually use gold this time to write the golden rule. XY arrow. I went 3 for x, so plus 3, and I went up 1 for y, so plus 1. That's it. That's the coordinate notation for this translation. And then let's actually perform a translation, and then we're done. We'll move on to reflection stuff. Translate the triangle according to the rule xy arrow, x minus 5, y minus 3. So recall, this minus 5 means left 3, or excuse me, 5. Your x's are horizontal, your y's are vertical. This means down 3. So remember, I said if you're good at counting, you're going to be good at performing translations. Why? All we have to do is go from A, left 5, 1, 2, 3, 4, 5, down 3, 1, 2, 3, boom, there's A prime. Same thing with B, 1, 2, 3, 4, 5, 1, 2, 3, B prime. 1, 2, 3, 4, 5, 1, 2, 3, C prime. All right, bada bing, bada boom, very beautiful. All right, such a beautiful triangle right there. All right, that's it for translation stuff. Now let's do reflection stuff. So name and specifically describe the transformation at the right. So what's going on over here? It's not too difficult. The most difficult part is saying, well, what line are we reflecting over? All right, students like to have a brain fart. Sometimes students claim this purple line I just drew is the x-axis. That's false. That's the y-axis. This is a reflection over y-axis. Neat. Cool beans. All right, we just identified a reflection. Now let's perform some reflections, all right? Give me a good color. Someone shout out a color. Ooh, telepathically, I heard someone just say red in their head. So we're gonna do this first one in red. We're gonna reflect -3, 1 over the x-axis. Remember, this is the x-axis right here. If you didn't remember that, well, it's labeled. All right, so remember, since it's 1 above, it's just gonna be 1 below. Boom. That's it right there. And let's write the coordinates, -3, -1, all right? X stays the same, Y changes signs. Someone say another color, and I'll hear you telepathically. Blue? Okay. All right, now we're gonna reflect over the y-axis, and by process of elimination, that's this one right here. And recall, since it is 3 to the left, it's gonna be 3 to the right. Points are equidistant from the line of reflection, all right, just like when you look in a mirror. And this time it becomes 3, 1. X changed signs, Y stayed the same from the original point. All right, now we got some quirky stuff going on here. What do I mean by that? Well, I heard someone already say green before I even asked. Someone predicted I was gonna ask a color. Okay, that's the line Y equals X. Or puff, puff, positive, puff, puff, positive. Remember, this is just the slope of 1 and a y-intercept of 0. That's how I know that's that line. But nonetheless, there's a couple ways to do it. My favorite way to do it is just actually remember the rule. You just swap the order of the points. It's 1, -3. 1, -3. Bada bing, bada boom. All right. Now, furthermore, some people say, well, I can go diagonally straight to the line 2 spaces, so I go 2 spaces past. You can count diagonals, it's just a little bit more careful. You can't goof it up. And notice how my diagonals that I counted were perpendicular to the line. And then last one right here, give me a good last color. Someone said pink. Weird how I can hear you telepathically in the future. I'm a very smart guy. Remember, the line y equals -x is just this right here. Wow, such a beautiful line. So pretty. And same thing, it has a slope of -1 until a y-intercept of 0. And this one right here, you just change the order of the points and change signs, so you get -1, 3, right there. And that's that point right there. Furthermore, we could still just count the diagonals, 1, 1. All right. That's it for this video. Stay tuned for some more really cool, fun review stuff.